let's start with this question number 1. So you have a big disk, larger disk of radius r, and smaller radii kitna beta? This rest of two disk ka radii, that is r by 50. They are in contact. Now they are having pure rolling. Gravity ignore karna hai aapne, and this omega, it is going towards this anti-clockwise, and with 2 omega it is going clockwise. After some time they'll meet again. And initially इन दोनों के जो centers है उनके बीच का separation, it is given in terms of delta theta. So you have to find out after what time their centers are going to meet again. Okay, so the thing is, इसको आप ऐसे imagine करो. Let's suppose I'm saying this as 1 and this is 2. So after some time 1 will be here, right? And 2, since it is having larger omega, so linear speed will be larger, so it will come up to here. तो ये इधर जा रहा है और ये इधर, they'll meet after some time. और ये एंगल आपका as it is delta theta रहेगा, right? Now let me take one thing here. So basically, if you imagine, it is this one is revolving about this O with omega 1, और ये जा रहा है about center with omega 2. So let's suppose this is V1 and this is V2. So how to connect these? So can I write down this V1 as omega r, because it is in pure rolling, and also if I see it with respect to O, it is omega 1 r plus r. Similarly for V2, it is omega r, sorry, it is 2 omega r, and if I see it with respect to O, it is omega 2 r plus r. So if I compare them, I can directly say that this omega 2 is nothing just twice of omega 1. Now ये relation say what we can calculate. So let's suppose first one is traveling some angle phi, right? And second one will travel this much angle. So using their omega relation, you can actually find out the ratio of their angles. For example, if you want to find out like this, theta 1. So if I take it as theta 1 and this is theta 2, right? So theta 1 ratio theta 2, definitely they are taking same time, so I can say it as omega 1t ratio omega 2t. So omega 1 ratio omega 2, and what we got this as 1 ratio 2, right? So you can say theta 1 will be 1 by third of the total angle. And how to find out total angle? You know one thing beta, theta 1 plus theta 2 दोनों मिलकर कितना चल रहे हैं? See, initially it is delta theta, and बाद में भी delta theta का gap रहेगा उनके बीच में. So this is going to be 2 pi minus 2 delta theta, right? So that is total angle. So theta 1 you can write down as 1 by third. See the ratio, 1 ratio 2. So 1 by third of 2 pi minus 2 delta theta, and theta 2 is like 2 by 3 of 2 pi minus 2 delta theta, right? Now directly from the question, one more thing you can get. See, this is first center, this is second center, this total distance, that is r plus r. So this is like up to here it is r, and this you can say it is r plus r, and this angle is delta theta by 2. So angle is very small, so delta theta by 2 is almost like r by r plus r. And as per question, this small r is given as r by, it is r by 50. Yes, so this will be, if I just put all the values, we are going to get it as 1 by 51, and that is in radian beta, right? So delta theta, that will be 2 by 51 radian. Okay, so you got angles theta 1 and theta 2, like the total angle traveled by each disk, each smaller disk, and delta theta, that initial angular separation you also got. Now you got delta theta. So how to calculate time? So see this pink or purple line. So that is the linear distance traveled by smaller disk. So I can write it as, with respect to O, I can write down that arc length as, it is theta 1 into r plus r, right? And that is also equal to the linear distance traveled by the disk. So it is like V1 into T. Now theta 1, if you see this, it is, you can write it as 2 by 3 and then pi minus delta theta and then r plus r, or V1 का वैल्यू बेटा it is omega into r and then T. So T का वैल्यू 2 by 3 omega pi minus delta theta and it is r plus r, so it is r by r plus 1, right? So if I put all the values, you are going to get 51 by 3 omega, then 2 pi minus, I'm taking this 2 inside, so this will become 4 by 51. So 51 by 3 omega, so that's your correct option. The outer का length is d, inner one length is d by 2, and 2n number of turns per unit length for the inner one and n number of turns per unit length for outer one. It's basically, you know, it looks like a transformer kind of system. Okay, anyway, so you have a resistor out, sorry, a capacitor outside, and then you have a AC source. So you have to find out resonant frequency. See, आपको actually करना क्या है, you have to convert this circuit into a simpler case like this. So this will be L equivalent, then capacitor as it is, you have this source. So in such case, omega is 1 by root LC, so L equivalent into C. That will give you the frequency. Basically, you have to find out F. So ओमेगा के लिए दिस इज द रिलेशन 1 बाई रूट एल इक्वलेंट इंटू सी. बट अब क्वेश्चन ये है कि बेटा ये एल इक्वलेंट निकाला कैसे जाए. इफ़ यू आर थिंकिंग दैट एल इक्वलेंट लाइक L1 प्लस L2 प्लस माइनस दैट 2m फॉर्मूला यू कैन अप्लाई, सो दैट इज़ नॉट गोइंग टू वर्क हियर. वो इसलिए क्योंकि ये रिलेशन कब यूज़ करते हो, जब दोनों ही इंडक्टर आपके सेम सर्किट में होते हैं, लाइक दे आर कैरिंग द सेम वैल्यू ऑफ करंट, राइट. बट यहाँ पे सिचुएशन अलग है. दीज टू आर basically, instead of that series or parallel combination of inductor, it is more like a transformer, right, with primary and secondary cell. So ऐसे case में how to find out this L equivalent, there is no direct method beta. That's why I say this is a quite interesting problem. So you do one thing first, let us find out the self inductance and mutual inductance of both of the coils. So L का जो formula होता है mu naught n square a by L. In this formula, n is total number of turns. मुझे यही formula याद है बेटा. So if you want to convert it into number of turns per unit length, so it is mu naught n square AL, right? And in this question, the small n is actually the capital N, correct? So let us find out L1. And one more thing better, in the question, they say this d square is greater than s, so that is basically the comparison of dimension. So you can say the length is very long as compared to the diameter. So that is basically it is telling you one thing, that you can treat them as ideal and you can neglect that fringing effect, right? So L1 mu naught, it has n square and that cross section area S, mu naught n square S, and that into D, the length is D. Now if I talk about the inner one, so it is mu naught total number of turns, like it is 4n square S by 2 cross section area, and length is D by 2. So again you got the same thing, mu naught n square SD. So basically L1 is equal to L2. Now let's find out this mutual inductance. इसके लिए कोई भी coil आप choose कर सकते हो बेटा. So let's suppose outer coil में current है I1 and inner coil में current है I2. So if I try to find out this mutual inductance for the inner coil, so what is magnetic field in the outer one? Mu naught Ni. N is number of turns per unit length. So mu naught N I1. Now for inner coil, area कितना बेटा? It is S by 2 and total number of turns 2n. Total number of turns, this n is number of turns per unit length. तो आपको length से ही multiply करना पड़ेगा. That will give you total number of turns. So this is going to give you mu naught n S, mu naught n square S d by 2 into I1. So this is behaving as m. So basically m12 from that principle of reciprocity, m21 is m, which is actually equal to L by 2, which is equals to L by 2. Now यहाँ तक तो बेटा this is for our use. Now the actual question starts. Now you write down EMF equation for both of the coils. So for coil 1, beta outer coil I'm saying coil 1 and this is coil number 2. So how to find out EMF in coil number 1? So it is minus L, I'm saying that L1 L2, let's say it is equals to L minus L d I1 by dt, that is because of self inductance, and then mutual inductance also. So it is minus M d I2 by dt because mutual inductance is coming from the second one, right? Okay, let's say this as equation number 2. Now for coil 2 के लिए कहाँ पे लिखेंगे बेटा? Let me write it here. For coil 2, minus L di2 by dt because it is carrying current I2, and then minus M di1 by dt. Now the interesting fact is this inner coil is shorted. देखो दोनों एंड आपने कनेक्ट कर दिया यहाँ पे. So the EMF induced in it will be zero. It will be zero. So from that case, you can write it as minus L di2 by dt, and M के प्लेस पे बेटा L by 2. This was d I1, बेटा ये I1 है यहाँ पे because it is coming from the first coil. So L by 2 di1 by dt, you put it equal to 0. तो यहाँ से you can easily compare that I2 is negative of I1 by 2. Very important result. I2 is negative I1 by 2. Okay. Now you directly use this in equation number 1. I see this equation number 1. E1 is minus L di1 by dt minus M के प्लेस पे बेटा L by 2, and di2 by dt if I do it as minus of di1 by dt और ये 2. So minus L di1 by dt plus L by 4 di1 by dt. Take minus outside, so it is L minus L by 4. So आपको मिलेगा 3L by 4 di1 by dt. This is for coil number 1. Current आपका I1 है यहाँ पे. So the E1, you can say it is equal to this. So this will be acting as L equivalent. अब आप क्वेश्चन पूछ सकते हो कि why we are taking it for only coil number 1. So बेटा coil number 2 का कोई relevance नहीं है यहाँ पे. I mean relevance in the sense it is simply affecting the current values in the coil 1. As a result, the effective value of inductance of coil 1 is getting changed. Basically, it is getting reduced. Lenz's law के basis पे it will oppose it, right? So आपके पास circuit में एक ही inductor है that coil number 1, but because of this presence of coil 2, its action is getting affected. So what is that new effective value of inductance shown by that coil 1? 3L by 4. ये finally appear होगा in the circuit, right? So that is like L equivalent. So omega का value 1 by root 3L by 4 into C. So omega is 2 by 3 LC. That is option number C. Okay, now question number 3. ये बेटा थोड़ा easy problem है. So it is moving with a velocity v naught, and v naught आपको given है बेटा यहाँ पे root gr by 3. It's under pure rolling without moving without slipping. Edge पे आके it is turning. और turn होते ही at the moment when cylinder loses the contact with the surface due to rotation around the corner, the speed of its center of mass is. So ये आपको निकालना है. So you can think of it this way. Edge पे imagine करो बेटा जब ये edge पे आएगा. So just before turning around this edge, this is the figure, and after some time it will be here, right? Center पहले यहाँ पे था, फिर center यहाँ पर आ गया. The center is getting rotated. So at this instant, it is still omega, initial omega, let's say omega naught, और यहाँ पर हो चुका है omega 1, और यहाँ पे लगेगा mg. Let's suppose this angle of rotation is theta. So technically this is also theta beta. So in downward, I mean, in this direction, just a minute. So in this direction, it is mg cos theta, and outer direction में लगेगा m omega 1 square r, right? If it is losing contact, these two forces are getting exactly equal. So one equation तो बेटा आपको यहीं से मिल जाएगा, mg cos theta will become m omega 1 square r. Beta, it is happening at the moment when it is losing the contact. Initially it is omega naught. Throughout the linear motion it remains omega naught, but turn लेने के बाद it is keep on changing. But exactly at the moment जब ये contact lose कर रहा है, let's suppose the angular velocity is omega 1. That's what the equation is representing. ठीक है, एक equation इसको मान लेते हैं, equation number 1. Now I'm assuming that even this turning is happening in a very, I mean, the friction is sufficient to hold any kind of slipping. So basically there is no work done by friction. So you can say the loss of energy is zero or negligible. So overall the potential energy ka change of fall hai, that will be purely converted into rotational kinetic energy. So mg, ye jo vertical height hai, that you can simply write down r1 minus cos theta. It is converting into half rotational kinetic energy. So beta, this point of contact ke about, it is 3 by 2 m square, and change in kinetic energy kaise likhna beta? So it's like fall, so you can write it as or you can write it as change. So it's omega 1 square minus omega naught square, correct? Okay, so this is change in kinetic rotational kinetic energy. अब इसको अगर आप simplify करते हो, let's see this equation. I'm going to solve it here. ठीक है, तो m r you can cancel, so you're left with g 1 minus cos theta, and then 3 by 4 mr square. This r already got cancelled, so anyway, so it is omega 1 square minus omega naught square. In next line, then g, I can do one thing. From this first equation I can write down gr value like this, and then 3 by 4 omega 1 square minus omega 1 square r minus 3 by 4 omega naught square. Now how to write down omega naught square? You see the given equation to us, v naught equals to root gr by 3, so that you can write down v equal to omega r. So omega naught will become it will be root g by 3r, right? So you can directly put it here, and okay, so this is g by 3r. I'm taking square, then you can solve it. So this g by 4 you can take on this side, so it will become 5g by 4, and then 3 by 4 plus 1, so that is 7 by 4 omega 1 square r. Okay, then omega 1 will be root 5 by 7 g by r. But in question it is asking you to find out speed of the center of mass, so that we can write it as v equals to omega 1 r. So v will become root within yes, so it is root 5 gr by 7. Directly you can write down. That's it. Question number 4, तो आपके पास एक double convex lens है. Refractive index is given to you beta, and both side it is having same curvature of 20 centimeter, and it is placed inside a refractive index NL. So basically you have this medium of eta L, not NL, and then you have this lens, right? So power अगर निकालूं मैं, so 1 by F, so it is 3 by 2, 1.5 है बेटा, तो 3 by 2 N or eta L minus 1, then 1 by, so this will be R1, so 0.2 minus minus plus 1 by 0.2, so 2 by 5, 2 by 10, 2 by 10, so that will give you 10. So power is basically 3 by 2 eta L minus 1 into this will be 10, and this power is in diopter because everything is in SI unit. Now you see eta L beta minimum आप कितना लेके जा सकते हो, 1. So when it is equals to air, So for eta L1 power हो जाएगा आपका 3 by 2 minus 1, 1 by 2 into 10, so that is 5. So this one is wrong, this one is wrong, and it is matching with 5, it is matching with 5. So you can have A and B option. But listen, it's not a linear function, right? So second one cannot be the correct answer. And one more thing, for eta 1.5, 1.5, I put it like this, 1 minus 1, 0, so power will be 0, right? Okay. And if I take for very opaque kind of medium, so eta L tends to infinity, power will actually tends to, so it will be minus 10 diopter. So basically that is the asymptote, right? So minus 10 to beta यहाँ पे A and B both are not going, but based on this all discussion we can say option 1 is correct, because option 2 is having the similar trend, but the only difference is a straight line, and this equation is not going to give you a straight line. So option A is correct. There is one more perspective. So inside any liquid medium or any medium, if I try to find out the power of a lens, so it is eta by f. F is focal length in air. So by that, if I go, I have to multiply by eta L or simply eta, then I'm going to get a straight line equation, which is represented by the option number B. But यहाँ पे I have that confusion because I solved it earlier by taking focal length in air, so power with respect to that. But inside the medium, if I take, it's going to be option number B also. Question number 5. Okay, so V, K, R, K, and KK, they are denoting velocity, orbital radius, and kinetic energy in any kth orbit, like nth orbit. The electron undergoes a transition from some nth orbit, and it is emitting a radiation corresponding to Lyman's rays. So technically what is happening, electron is starting from n and it is jumping to n equals to 1. So for this case, you have to verify these 4 options. And I think this question is a little bit tricky. If you, not tricky, lengthy, you can say, if you don't know the direct formulas for velocity, radius, and kinetic energy. So let us find it. So I'll do this calculation here. I have pretty much space here. Okay, so let's start with the basic equation. एक तो बेटा फोर्स के लिए सेंट्रल फोर्स एंड देन ई स्क्वायर बाई 4 पाई एप्सिलॉन नॉट r स्क्वायर. तो यहाँ से आपको रिलेशन मिलेगा mv स्क्वायर इक्वल्स टू ई स्क्वायर बाई 4 पाई एप्सिलॉन नॉट r, लाइक दिस. और एक इक्वेशन आपके पास और होती है बेटा, एंगुलर मोमेंटम, दिस इज nh बाई 2 पाई. सी एज पर द क्वेश्चन इट इज k, सो बट ठीक है, वी आर लर्निंग इट इन टर्म्स ऑफ n, तो बेटा हमारा n ही एक्चुअली k है यहाँ पे, right? So this is equation number 2. So if I divide these two, and आपको v और r के लिए equation यहाँ से मिलेगा. So v square equals to e square 2 epsilon naught nh v actually, and then r in any nth orbit it will be n square h square epsilon naught by pi m e square. अब काइनेटिक एनर्जी आपको निकालना है बेटा. व्हाई आई एम फाइंडिंग काइनेटिक एनर्जी? लिसन, फर्स्ट क्वेश्चन देखो, मैग्नीट्यूड ऑफ चेंज इन काइनेटिक एनर्जी ऑफ इलेक्ट्रॉन, मतलब n से 1 तक आएगा, सो दैट इज द मैग्नीट्यूड. अब आप देख रहे हो काइनेटिक एनर्जी में यू हैव v और n, तो टेक्निकली आपको काइनेटिक एनर्जी निकालना है इन टर्म्स ऑफ वेलोसिटी इन nth ऑर्बिट एंड रेडियस इन nth ऑर्बिट. सो काइनेटिक एनर्जी इज हाफ mv स्क्वायर व्हिच इज me स्क्वायर एंड देन इट इज 2 4 epsilon naught square n square h square, right? अब यहाँ पे थोड़ा सा मैं स्किप करके चलूंगा बेटा, बिकॉज आई हैव ऑलरेडी सॉल्व्ड इट. सो एक्चुअली आई गॉट इट एज e स्क्वायर 8 पाई एप्सिलॉन नॉट r. एक्चुअली आपको r के फॉर्मूले में इसको कन्वर्ट करना है, देन v के फॉर्मूले में भी कन्वर्ट करना पड़ेगा. तो उसके लिए इट्स लाइक nh नहीं है तो nh से मल्टीप्लाई एंड डिवाइड. सो फाइनली इट इज v nh by 4 pi r. Now find out change in kinetic energy. So it will be like n से 1 जा रहा है बेटा. So if I find out that change, so just magnitude, so h by 4 pi you take outside, and this will be n vn, because nth orbit में n and v is like vn by rn minus, now first orbit के लिए 1 into v1 by r1, and it is matching with that given option. See this first option, A option, so that is correct, right? Okay, now second option, it is asking magnitude of change in de Broglie wavelength. अच्छा, de Broglie wavelength के लिए lambda equals to h by p, और p को आप लिख सकते हो 2m into kinetic energy. So h by root 2m, and then it will be root k in nth orbit, like that you can do. But if you see the option, it's something else, and it's not in the form of h by root 2m, so it's not going to match here. Direct straightforward you can say. So this one is correct, this one is wrong. Now frequency of radiation emitted can be expressed as, इसके लिए आपको थोड़ा साइन का ध्यान रखना पड़ेगा. So the thing is, this E is actually negative of that kinetic energy. So we know this relation HF, that is, it's like En minus E1, right? That is delta E, and then it is equals to negative of kinetic energy. So it will become kinetic energy 1 minus kinetic energy in nth orbit, right? So from this relation, F ka value, and kinetic energy ke liye you can use this relation better, this one. So E square by H, I'm taking outside, this H is coming downside. So 8 pi epsilon naught, it is 1 by R1, 1 by Rn. And yes, it is matching. Now last option, the magnitude of change in total energy of the electron can be expressed as. So energy, you see it is represented in terms of V and R. So first of all, you can use this relation, kinetic energy in terms of V and R. So it is NHV by 4 pi R. So kinetic energy relation NHV by 4 pi R. And we know that energy is negative of that kinetic energy. So it is NHV by 4 pi R. So if I want to find out delta E, which is En minus E1, so it is minus H by 4 pi, and you can write it as N Vn. Then negative negative becomes positive, H by 4 pi, and one more thing better, it is Rn, and then it is 1 V1, so it is V1 by R1. So if I take the common thing here, so it is H by 4 pi, it will be V1 by R1 minus NVN by Rn. So if I see this thing, it's not matching. There's a factor of 2 extra here, so this is not the correct option. Little bit lengthy, but yes, it's a easy problem. Question number 6. So I think this is one of the easiest problem. So you're projecting a projectile and it is actually passing through this P point. So you have to verify these options, and it is actually passing through one of the coordinates. So if I imagine origin at this point, like this as X, this as Y. So one of the coordinate is 5, 1. So I can use this relation, the equation of trajectory. Y equals to x tan theta minus g x square by 2 u square cos square theta. Okay, so option A and option B you can verify using this. So y is basically positive 1, x is 5. So if I put like option A, I want to check. So 1045, that is 1 minus g, and x is 5. So that is 25 by 2 u square, and cos 45 1 by root 2 square, like this. So if I calculate v from here, and that is correct, like root 5 root g by 2 meter per second. So option A is correct. But if I try to check option D, tan theta will become 1 by 5. So it's like, I mean, I'm not putting it here, but if you directly put the value in this particular equation, so for D, if I put all these parameters, then V, you are going to get it as infinity, because 1 minus 1 0 case you are getting. So 1 by V becomes 0. So that case you are getting. So this is not the correct option. Now B and C, how to verify it? You can do one thing better. For each case, you can find out the range. You can find out the range, right? For both of the cases, you can find out the range. Then you take the half. So basically what it is asking, if theta is 45 degree, the particle reaches its maximum height before it reaches P. So at exactly R by 2. So for any projectile, at exactly R by 2, it is at maximum height. So do one thing, for each of the case, you find out R, then you do R by 2, and then you compare with 5, right? So if R by 2 is less than 5, then maximum height has already arisen, right? So based on that, you can verify it. Question number 7. This one is again easy. So let's verify it. So as per question A to B, beta, you have isothermal process, and then C to A, you have adiabatic, and B to C, that is isochoric. Okay, Q in is representing total input amount of heat and Q out is rejected, and we know this formula. This is how we are finding the efficiency for any cyclic process. And all the processes are quasi-static, right? Okay, so let's verify the first option. Heat released in the process BC is smaller than the heat absorbed in the process AB. This statement, I can say it is actually independent of even this ratio. Why? See, uh, it's a cyclic process and it is clockwise. So beta work done is basically non-zero, and you can say it is actually greater than zero. It's a positive work done. That means Q in must be greater than Q out, right? And for C to A, there is no heat changes. So basically Q in is happening only for AB. So that is basically QAB. And Q out is happening for this B to C. So this value is actually negative and this value is positive, right? So if I just compare the magnitude value, so intake should be greater than outgoing. That is the result. Otherwise, even if they are equal, work done will be zero. So basically Q in should be greater than Q out. So Q in, that is for process AB, and Q out, it is for BC. So as per the statement, the heat released in the process BC is smaller than the heat absorbed in the process. Just compare the magnitude better, right? So this one is correct, right? Now for a given value V1 by V2 by V1, eta does not depend on temperature of isothermal process. This part is actually you have to solve it properly. Okay, so let me start it again. So I'm rubbing this part better. That is for the option number one. Now B option के लिए first you find out delta Q AB. So beta in this process there is no delta U, so it is basically equal to the work done. So NR TA, see A to B you have one single temperature. So let's say it is T, simply T I'm saying. TA equals to TB equal to T nRT ln V2 by V1. Now delta Q BC, as I said, is rejected, so negative, and since it is isochoric, so no change in volume, hence work done is zero. So this is actually equal to minus delta U. So it is N CB delta T. So it should be TC minus TB, but because of this sign, it will be TB minus TC. Okay. Now eta के लिए you have to use this. So Q in minus Q out. So it is 1 minus Q BC by Q delta Q BC by delta Q AB. Right? This way you can rearrange it. So it is 1 minus NCV TB minus TC divided by nRT ln V2 by V1. Now after this, eta equals to 1 minus N, you can cancel. So CV by R, and TB and TA, that is equal to T. So if I take it outside, it will cancel out. So numerator you got 1 minus TC by T or TA ln V2 by V1. Now for a given value of V2 by V1, eta does not depend on temperature. Which temperature? Isothermal. Basically it should be independent of T. Yes, we can convert it into different forms. See, for A to B, or better to write A to C, we can use this relation. So TA V1, because at A we have V1 to power gamma minus 1, TC, or better write TC, it is V2 gamma minus 1. So TC by TA, which is actually TC by T, so that will be V1 by V to the power gamma minus 1. So if I put it here in place of TC by T, so the whole expression will become independent of T. So this one is correct. Now, how to verify option number C and D? That is easy. So for C, V2 by V1 is 8, then temperature at A is 4 times as compared to C. So you directly use this relation beta. So TC by TA, V1 by V to the power gamma minus 1. And what kind of gas it is? it is monoatomic, so gamma will be 5 by 3. Gamma is 5 by 3. So it is gamma minus 1, 5 by 3 minus 1. So Tc by T, Ta, now it is 1 by 8 to the power 2 by 3. So Ta by Tc will be 8 to the power 2 by 3. So that is like 4 times. So basically Ta is 4 times of Tc, and that is correct. Option number C is also correct. D, how to verify? So A and B point, that is isothermal, so you can write it as like Pa V1 equals to Pb V2. Now from here Pa by Pb, that is V2 by V1. V2 by V1 is 8. It is 8 times, not 4 times. So this is wrong. So A, B, C are correct options. Question number 8. So you are given for an electromagnetic wave, the electric field vector is given by E naught sine 3y 3y plus 4z plus omega t I cap. Basically, that electric field is pointing in the positive x direction. But how to find out the traveling direction? So if I compare it with the general equation sine omega t, then plus minus k dot r, or simply plus k dot r. That is how you are writing the general equation, right? So if I compare that, k vector is 3 I cap plus 4 k cap, right? And you have a plus here, so electric field, or in general, that EM wave is actually traveling in a direction negative k cap. That is how you're finding the direction. So direction is represented by k cap, and negative y because you have a positive here. So it is negative 1 by 5. The magnitude is 5. 3 I cap plus 4 k cap, right? So option number A is correct. The magnitude of wave vector. So k ka magnitude is 5. It's not 0.5. And so it is wrong. C option. You can use V equal to omega by k, and V is nothing, just C. So omega is k into C. K is 5, C is 3 into 10 to the power 8. So 5 into 3, 15. I can write it as 1.5, and then 10 to the power 8, and then one more, it will become 9 radian per second. So that is correct. How to verify D option? So that is the magnetic field. See, magnetic field ka direction is given to you, so we can directly verify it. So you can think of it this way: E cap cross B cap, that is actually giving you K cap. So E cap, that is represented by I cap, cross, I'm choosing directly this. So 1 by 5, B cap is 4 J cap, 4 J cap. I'm assuming this as correct, then I'll verify it. 4 J cap minus 3 K cap. And this K vector, where is that propagation? So it is minus 1 by 5, 3 I cap plus 4 K cap. LHS, if you see, it will be 4 by 5 I cross J, that is K cap. Then I cross K, that will be minus J, so plus 3 by 5 J cap. 4 by, and that is not matching. It is basically not equal to this because you have negative this side, right? Okay. So option number D is also wrong, because this k is actually representing the direction of propagation. So wave is propagating in minus k cap, right? So its direction is actually represented by this. Or instead of writing it as k cap, you do one thing. You can see k vector you already have here. So, and k is representing the direction of propagation. So better you write it this way. So k cap will be this. I think that is correct way. So k cap is negative 1 by 5, like this. Now, question number 9. So you have a tank. It is filled with two immiscible type of liquid. So as per the question, the high density liquid is filled up to height L by 2 from the bottom. So this one is actually 6 row, and this will be 2 row. And this complete height of the rod is L. So basically up to here it is L by 2. So I can say this point is exactly at the middle. Okay, so if I, and at this point it is kind of pivoted. and assume there is no friction at that pivot point. So if I slightly, right or left, if I give it some kind of oscillation or just disturb it by some small angle, it will start oscillating, and that time period you have to find out. Okay, so basically we have to write down the equation for restoring torque here. So how to start? So let me again draw the complete figure. So the situation will be like this. This is that initial, you can say, that equilibrium line, and then the rod is getting shifted little bit towards right at an angle theta. And one more thing better, see, the angle is very small. So initially the center of mass of the rod, as it is uniform, it is exactly here. So it is hardly displaced by any amount like up and down. So it's almost same there. Why? Because angle is same here, right? Angle is very small actually here. That's why I can say the center of mass is actually not shifting up and down, right? Now after that, okay, so the lower portion, uh, at the middle point of this, you'll be getting, let's say this lower liquid is 1, upper liquid is 2. It is 2 row and this is 6 row. So from here you're going to get F1, that first wind force, and at the center of upper portion you have F2. And for rod, it is, you can imagine that it's actually given, it has density rho and length is L, right? Capital L, small l, you can check it later. Okay, now solve it. So if I take it to the right side, towards right, and then release it, it will start oscillating this way, right? So you have to write down restoring torque about O point. Restoring torque about O point. So I'll put minus because it's acting in opposite sense of theta. So one restoring torque you are getting because of F1. So F1, and see, this length, it was L by 2. Complete, it is L by 2 up to here. So half of that L by 4. So L by 4, and what is this perpendicular distance? That is L by 4 sine theta. And for above liquid F2, okay, up to here it is L by 2, or यहाँ पे बेटा further L by 4 you have to add. So basically 3 L by 4. So O up to this point, the total distance, ये distance बेटा 3 L by 4. So 3 L by 4, then sine theta. And if you see, gravity ka torque is acting reverse in the direction of theta. So it is minus mg, and that is L by 2. L by 2, and then it is sine theta, right? Now let's further simplify it. So buoyant force for the lower portion of the rod. Density कितना बेटा liquid का 6 rho density, and then cross section area A, and length is L by 2 into G, L by 4 sine theta, plus for upper liquid, for the upper portion of the rod, 2 rho A, L by 2 G, then 3L by 4 sine theta. And mass of this rod, you can write it as density into volume. So rho AL, then G, L by 2 sine theta. And this is about O point beta, restoring. So if I take it rho AL square G, and even sine theta also outside. And see, theta is very small, so you can take that theta outside like this separately. Okay, so what is left? So it is 3 by 4, and here also it is 3 by 4. So 3 by 4 plus 3 by 4, that is 3 by 2, and then minus 1 by 2. So technically it is rho A L square G, and then theta. Now this restoring torque about O, that should be equal to I alpha. So I for the rod, it is ml square by 3. So m L square by 3, that is I alpha, and then it is equals to rho A L square G theta. So from here, alpha is L square, you can cancel out first. So it is minus rho A G and 3 actually. So it's minus 3 rho A G by m, and then theta. Mass you can write down. So mass is rho A into L. So ultimately you got 3 G by L theta. Now if I compare with the basic equation of any SHM, so alpha must be minus omega squared theta. So omega beta, how much you got? 3g by L. Then time period is 2 pi root L by 3g. All the given values are there. So if you put everything into the, you just compare it. Actually, in question, it is asking you to compare. Yes, 2 pi by N, L by G. So that 3 you have to take outside. So basically, as per the question, this N will be root 3. N will be root 3. Now question number 10, and I think this is one of the interesting question from this exam paper, paper 1. So you have multiple Carnot engines, basically 5 Carnot engines, and as per the question, the net efficiency is given like this, 211 by 243. So you have to find out eta. What is eta? Eta is efficiency of each single engine, and each single engine is doing work W, right? Okay, and they are connected in series like cascade format. So you have to find out eta. So how we can proceed? If you carefully observe it, so better I can take it as first engine, and then this is second. So first engine. So you can think of it this way: first engine is taking Q naught heat, and then last one, fifth one, it is rejecting Q5, and it was taking Q4 and it is rejecting Q5. So eta net की अगर बात करूं, so what is intake at the initial point? Q naught. What is final exiting to the surrounding, or not surrounding, you can say to the sink, that is Q5 divided by Q naught. So it is 1 minus Q5 by Q naught, and it is given to you. और वहां से आपको ईटा का वैल्यू फाइंड आउट करना है. सो आवर टास्क इज थोड़ा सा मैथमेटिकली आपको समझना है यहाँ पे. इफ आई कैन राइट डाउन Q5 in terms of Q naught and then some extra coefficient, and then I can easily compare it with 211 by 243. So that is giving you a chance to find out the value of eta. Okay, now how to proceed it? So you imagine any nth engine. तो nth engine का जो intake होगा बेटा, that will be Qn minus 1. Why Qn minus 1? देखो 1 को मिल रहा है Q naught, ऐसे 2 को कितना मिलेगा? Q naught minus W, क्योंकि वर्क डन हो चुका है, right? That is actually Q1. So whatever the number of engine is, आपको, I mean whatever the number of that working substance is, it is getting Q and then subscript 1 less than that, right? So 1 के लिए Q naught, 2 के लिए Q1, 3 के लिए Q2. In that way, nth के लिए you are getting Qn minus 1, and the rejecting part will be Qn, one more, and as a result it is giving you work done W. So you can say Qn minus 1 minus Qn equals to W. ये है equation number 1. Also, if I talk about eta of any one of the engine, so they all have same and they all are doing same work. So it's just W divided by. So if I talk about this nth engine, its efficiency is eta. It is doing W work, and what is the intake for it? Qn minus 1. This is the intake beta, right? So work done is eta Qn minus 1. This is equation number 2. Now just combine them. So what you'll get? So from 1, Qn minus 1 as it is, and वर्क डन को इधर लेके आओ, नेगेटिव W, सो दैट विल बी ईटा Qn minus 1, और ये Qn राइट साइड जाके पॉजिटिव. So Qn will be Qn minus 1 minus eta. Now we are close to get that recurring kind of that repeating kind of formula here. Okay, so you got this. So you think of it this way: अगर मैं n की जगह पे 1 लेता हूँ, if I'm talking about the first engine, so 1 minus 1, so that is Q naught 1 minus eta. अगर मैं Q2 की बात करूँ, so it should be Q1 then 1 minus eta, और Q1 का वैल्यू ये है, right? So it's kind of iterated equation, like it's keep on taking the previous value and then number of iterations you are running up to 5. So it's like Q naught 1 minus eta 2 square. So let's just think about the last one, Q5. वही तो चाहिए आपको यहाँ पे, right? So Q5 will be Q4 like this, 1 minus eta, but Q4 को आप directly can write down terms of Q naught. Already it will be 1 minus eta to the power 4. एक और मिलेगा power यहाँ पे. So 1 minus eta to the power 5, right? Now the final step. इसके बाद, so I'm using this. So 1 minus Q5. Q5 का value if I put Q naught cancelled. So 1 minus eta to the power 5, and this net efficiency beta आपको given है, that is 211 by 243. 211 by 243. So 1 minus eta to the power 5, 1 minus 211 by 243. So 243 minus 211, so that will be 32 और ये 243 as it is. बेटा 1 by 5 कर दो पावर, so 2 to the power 5 अपने को पता है 32 होता है, so it will be 2 और ये आएगा आपका 3 के लिए, you can verify it. So finally eta is 1 minus 2 by 3, so that is 1 by 3. That's it. Now question number 11, and ये भी बेटा interesting problem है. So let's first try to understand the problem. So you have a insulated container. थोड़ा सा explain करता हूँ बेटा इसको मैं. And ये P1 जो है ना, it is actually a fixed piston and it is not allowed to move, but it can conduct. It has some conductivity. Okay. So basically, heat energy can go from left to right. Okay. And here it is free to move. Piston P2 is free to move. There is no kind of any kind of constraint. So it will be always in equilibrium with the surrounding. होगा ही बेटा. Outside you have P naught, you have air, and here inside it has to be P naught because it is without any constraint it can move easily, right? Okay, so initially क्या given है आपको S1 and S2 section, like this is S1 and S2, इनका temperature difference is delta T naught. So you can think of it this way, suppose यहाँ पे temperature है T naught, so it will be T naught plus delta T naught, correct? So S1 section is having more energy, so what will happen through this P1, it will actually getting conducted to the S2 section, right? But S2 section में gas can expand, but its pressure remains constant. So basically it is isobaric process, and first one you can see P1 is not movable, so it just remains fixed. So this is isochoric process, and S1 से S2 heat energy can transfer. And each section has 1 mole N1, N equals to 1 of what kind of gas? It's given somewhere. Yes, it is containing 1 mole of monoatomic gas in the each section. Now, what happens since S1 is losing heat energy, so its temperature will change. So basically, you have to find out if initial temperature difference is delta T naught, after what time this temperature difference will become delta T naught by 2. And it is given by this. So you have to find out the value of N. Okay, let's start. सबसे पहले you can start with that conducting equation, that Faraday law. So what you will do, through that x length it is heat is exchanging, so dq by dt, that will be k. A is the area of this P1 plate, and then it is T1 minus T2 by x. Now अब T1 और T2 क्या है बेटा? See, as I said, initial temperature of S2 is T naught and it is T naught plus delta T. So S1 का at any instant it will have some temperature T. So it's a function of time, and T2 is also a function of time. So at any particular instant, section 1 will have T1 temperature, section 2 will have T2 temperature. So that temperature difference. Basically यही temperature difference आपका delta T naught by 2 होगा. So after how much time we have to find out. Like this. Now for 1 if I talk, it is isochoric. So I can say delta Q, and it is losing heat energy better to the section S2. So delta Q is NCV. Better to write it as dq for a small change, dt1. Now what is dt1? This is exclusively for section 1, and dt1 is representing the heat change in section 1, right, in a small amount of time. So dq, number of moles 1 minus 3 by 2r dt1. Equation number 2. For section 2, it is isobaric and it is absorbing heat, so delta q is positive, ncp dt2, right? So it is 5 by 2r dt2. This is equation number 2. Now यहाँ पे थोड़ा सा mathematically आपको ट्रिक खेलना पड़ेगा बेटा. What is that? So in this equation I'm finding dt1, a small change in temperature of one section. So this will be 2 by 3r, and this is dq, and from here dt2 will be 2 dq by 5r. Now what I'm doing, I'm taking this difference dt1 minus dt2. इस टाइप के बेटा एक दो क्वेश्चन फिजिक्स गैलेक्सी दैट 700 something, some illustration book is there, so you can see, you can check that book. 2-3 questions are there exactly similar to this. So dt1 minus dt2, if I do it, we can say it exactly like d t1 minus t2 like that. So it will be d of delta t, because t1 minus t2 को मैं एक वेरिएबल मान के चल रहा हूँ delta t, right? Okay, so d of delta t. Now as you are subtracting them, तो साइड वाइज भी आपको लिखना पड़ेगा ये. सो बेसिकली d delta t, बट इसकी वैल्यू कितनी बेटा? d t1 minus 2 by 3 r So minus, if I take outside, 2 by 3 inside, and minus it will be plus 2 by 5 dq by r. So it is 10 plus 6, it will be minus 16 by 15 r, and dq ka value you can take it from here. So it will be ka delta t by x into dt. Yeah, dt will go towards right now. Okay, now after this we are very close to that final integral equation. So you can separate similar type of variable here. So beta d of delta t divided by delta t. Now this makes sense. You can easily integrate it. So minus 16 by 15 r k a x as it is, and then dt. Integrate, integrate. X is not a variable, but x is actually the width of that conducting plate. Okay. Now t equal to 0 पे ये जो delta t था, it was delta t naught. Now at any later time it should become delta t naught by 2, right? So it will be ln, and ln my upper value is smaller than the lower value. So if I do it like this, negative outside liya, so it will be delta t naught, I mean, upper minus lower minus upper you can do. So delta t naught divided by delta t naught by 2. So this will become ln 2 negative mein, right? Minus 16 by 15 KAT by Rx. So minus minus cancelled. Now T ka value is ln 2 15 Rx by 16 Ka. Now that value, if you calculate, I'm not calculating it here, it will be coming as 0.66 seconds. Question number 12. So you have a hollow right circular cone, and it should be X, Y, and then Z. Okay, so along, first of all, this is hollow and it is having a surface charge which is uniformly distributed. Okay, and it is rotating with omega. So along the Z axis at some point Z, which is greater than this height h, basically it's a far point, you have to find out magnetic field strength. Okay, beta ये question अभी तो it's easy because the distribution of mass and distribution of charge is having proportional ratio here. You can say they both are uniformly like equally they are distributed. But अगर ये solid cone होता where mass is distributed differently but charge is distributed only over the surface, तब ये it will become definitely a very tricky question. So in this case it's hollow, so we can actually apply this q by 2m equals to magnetic moment by angular momentum. Why I'm applying this thing? Because mass or charge का distribution है, it is proportional to each other, right? That's why we are allowed to use it, and as a result this question becomes easy. Okay, now magnetic moment you have to find out. Now you can ask why I'm finding magnetic moment, uska bhi relevance hai beta. So let me first find it. So q by m into l, q by 2m, sorry, and l. Okay, it's a hollow cone, so its moment of inertia will be similar to that disk. So mr square by 2 into omega. So magnetic moment will be q r square omega by 4. Okay. Now after this, see what I mean. How you are expecting current here? It is actually arising because of the rotation of the charges over the surface. So you have, I mean, if I take a small section, you can imagine a small section here. It is having current this way. फिर एक section यहाँ पे imagine करा तो यहाँ पे translational current है because of the rotation like this, right? So you can imagine there are large number of such coils. They all are carrying current in the same direction. So if I try to draw the magnetic field lines, so the upper face is behaving like a north because current is moving like this. So upper face is like a north and lower is behaving like a south. You can imagine field lines like this, right? So you can actually replace this rotating cylinder by a large, you can say a long bar magnet, right? A bar magnet where you have north here and south here. That's why I was calculating the magnetic moment, because you can treat this as a long bar magnet and then this z point is somewhere on the axis. So magnetic field along the axis का formula लगा सकते हो बेटा, mu naught by 4 pi 2m by r cube. So from origin that is actually z cube. So B equals to mu naught by 4 pi 2 by z cube, m का value q r square omega by 4. So You have to compare it with this given thing. So q r square omega इधर है बेटा 4 pi b है नीचे. So 2, if I cut it, it is like 1 by 2. ठीक है, everything is matching except that 1 by 2. So that you can replace by n. So basically n का value is 1 by 2, which is 0.5. 13. So this question is kind of easy. Actually, in all the cases, what is happening, you have a sound source S, and then it is splitting the sound waves. Finally, a detector, you are getting, these waves are getting detected. So at D point, it records a maximum amplitude, basically a constructive interference. So you have to find out the minimum value. So because list 2 contains the possible smallest value of L, that is the dimension of the tube. So in all cases, you write down, so basically the process for each of the option, you have to write down the expression for path difference. And for constructive interference, it should be equals to N lambda. Now path difference, that will be in terms of L. Definitely it will be in terms of L. This example, if I take this case, what is path difference? Upper one is traveling pi r, lower one is traveling 2r. Pi minus 2. Now what is r here? R is actually L by 2, right? Now this should be equals to n lambda for constructive interference. So it is 2n lambda by pi minus 2. So n, you can start from the least value. So what is the least value of n? It will be 2 lambda by pi minus 2. So like that you can find out in each case. Question easy है बेटा, but it is calculative. Like pi minus 2, like very close values you have to calculate. So time consuming है. So these are some of those questions which you can solve, but अगर calculatively आपको already exhausted है, you can skip it. Right? इसमें आपको लाइक आउट ऑफ पी क्यू आर एस अगर आप तीन भी वेरीफाई करते हो तो आपका हो जाएगा. जैसे एस वाला आप देख रहे हो, ऑल द ऑप्शन लाइक 1 2 डिफरेंट आर देयर. सो इवन इफ यू स्किप एस यू कैन स्टिल गेट द आंसर, बट फिर भी आपको बता देता हूँ मैं लाइक एस में हाउ टू फाइंड आउट दैट कंडीशन. सो यू पुट वन परपेंडिकुलर हियर. सो सपोज ये सेक्शन अगर एक्स है बेटा तो ये भी एक्स होगा. एंड सिंस इट इज लाइक ये 90 45, so this is 45, and this one will be 105 minus 45, that will be 60, and यहाँ पे ये 30, right? So you can do one thing. तो ये बेटा x root 2 this will be, और ये x है तो based on this 30 degree it will be root 3x. And what about this hypotenuse? So that is sine component, so it will be x, this will be x root 3. No, it will be sine and beta, so it will be 2x, sorry. Now the path difference for this case will be upper wave, how much it is traveling, x root 2 plus 2x, minus lower one it is traveling x plus root 3x. और आपको x की वैल्यू कैसे मिलेगी? x plus root 3x, it is already given as L, right? So that you have to put it here. और फिर आपको मतलब x को आप L की फॉर्म में रखोगे and then n lambda. Technically it is kind of very calculative, which is going to be a calculative problem. बहुत close terms रहेंगे आपके पास. So that way it is kind of difficult. Question number 14 is easy. I mean, it's theoretical portion, and I hope you all have done this. So that's an easy portion. I'm skipping this part. You can just go through the theory portion, you'll get the answer. Now, next one. This question is easy. This question number 15 is easy, and as well as it is interesting. So let us try to find it. Okay. So you have different conditions given on the left hand side. I mean, basically they are giving you different shape of the wire frame, and then on right hand side you have a uniform magnetic field, and then because of that rotation it is going to generate some induced current. Okay, in all these cases, अगर आपको theory याद है बेटा, so in none of the cases you are going to get fifth one. The reason is, let me take one single case, a general case you can say. ये आपका theory का portion है. So this is B here. Now imagine you have this kind of a sector kind of conducting loop, and suppose theta angle it has entered, right? So जो EMF आएगा, हम EMF कैलकुलेट कर लेते हैं because I is proportional to that. So EMF is this delta phi by delta t, and suppose it is rotating with constant omega, right? So B into area, what is the area of this section? That is pi r square by 2 pi, like per unit solid angle, and then into theta. Theta is actually in radian meter. So b into area, and यहाँ पे delta t. Better to write it as delta theta, right? Small angle it is entering. So b r square by 2 delta theta by delta t, and this will give you omega. So if omega is constant, then emf is going to be constant, तो current भी आपको constant मिलेगा. But suppose you have a case where you have alpha there, like angular acceleration is there, where omega is keep on increasing. So in such case, if you have a constant omega, then constant alpha, then omega will be like alpha t. In that case, emf induced will be proportional to the time, and you're going to get a straight line. ये वाला graph, fifth one. But in our cases, in all the cases like PQRS, if you consider, all are having same omega condition. So fifth तो किसी का भी नहीं होगा, right? So you can compare on that basis अगर कुछ आंसर आपको मिलता है तो. So जैसे P का 5 यहाँ पे दिया हुआ है, that is not possible. एक इसका भी 5 यहाँ पे given है, and 5 है यहाँ पे, R का 5 यहाँ पे given है. And this is the only option, the C option, where none of the wireframe is having that fifth as a option, right? So you can directly say this will be the correct option, but फिर हम एक बार verify कर लेते हैं. I hope it is clear to you. So let's talk about this. So first case में, see, जब तक ये वाली कंडीशन में नहीं आ जाता बेटा, it is keep on, I mean the fluxes keep on increasing, outcoming fluxes keep on increasing, तो EMF आपको मिलेगा. After that, it will immediately become negative, because when it is starting coming out, flux आपका decrease. So up to some instant of time, like half of the time, you can say half of the time EMF will be constant, and current will be constant. I mean, and after that, immediately after t by 2, it will become negative. So ये आपका 3 मैच कर रहा है. So Q के लिए 3, is it in our option? Sorry, P के लिए 3, yes, it is there. Now let's talk about Q. So Q के लिए आप देखो बेटा, when this portion of frame is entering, flux is increasing, so you'll have current like this, right? फिर उसके बाद आपको एक गैप मिलेगा. इन दैट गैप नथिंग इज हैपनिंग. वंस दिस पोर्शन इज एंटरिंग, देयर इज नो फर्दर चेंज इन द फ्लक्स. मतलब मैं ऐसे टाइम की बात कर रहा हूँ बेटा, like this. There's no change in flux, right? So it will get immediately zero. The moment the second arc, the second sector starts coming into the magnetic field, immediately EMF आपको मिलेगा. But उसके लिए भी आप देख रहे हो, flux is increasing in outward direction. So again, it's like a gap, zero current, and then again it is like this. And then when the whole portion is inside, तो यहाँ पे आपका t by 2 time over. उसके बाद फिर lower section will start like same way, right? So it is represented by 2, right? So Q का होना चाहिए 2. Yes, it is matching. अच्छा, R के लिए it is going inside. Once it is inside, I mean this length, this portion of wire is inside, there is no further change in the flux. So लंबा gap आपको मिलेगा in the current, right? So like this, best matching, right? For this S and last part, see, you can see the figure. When this portion is entering, once it has entered, there is no change in flux. So when it is moving up to last, up to this, till the moment it is coming here, there is no change in the flux. So current is zero. But think about a case when the situation is like this. Like this. So this part is entering and this part is leaving. So in this part, flux is increasing. In this part, flux is decreasing, right? It is increasing and it is decreasing. So overall you can say the overall change in the flux will be zero. So even for such case, like both of the triangle part are having their sum of the portion inside the magnetic field, still यहाँ पर भी आपको EMF में zero value मिलेगी, because overall change in flux is zero. So S के लिए throughout the motion, throughout the complete rotation, current will be zero, right? Now, finally, this last question, it is question number 16. This one is again easy beta. So if I closely observe all these P, Q, R, and S categories of, I mean, these figures, in every figure, you have to find a moment of inertia. And one thing is common. I mean, imagine this is the axis of rotation. Then you imagine a rod. Let's suppose this angle is theta. It has mass M and length L. Let's suppose this axis is A. So as per theory, moment of inertia about it, M L square by 3 sine square theta. Doesn't matter if this rod is oriented this way, even if it is downside theta, again you'll be using the same relation. So here you can apply theta is 45, 45. This you have two rods, 45, sorry, 60, 60 you can apply. And for this rod separately using that parallel axis theorem, you can find it. And here each rod is oriented with axis at 45 degree. So just एक का निकाल के 4 से multiply करो. Here both are oriented at 30 degree. So एक का निकाल के 2 से multiply करना है. That's it. It's easy one.